Hi, welcome to Concept Based. I'm John Hepworth. This is a Year 11 extension question. We are in the permutations and combinations section of your syllabus. And as is always the case, I prefer to use questions to try and give an explanation of definitions. So the very specific thing that we're talking about are permutations today. And I don't want to go ahead and just tell you what a permutation is. I want us to actually try and derive it in a way from the basis of doing a question. What I will do, however, is I will show you that it is on your formula sheet. So in the combinatorics section of the formula sheet, you have a range of equations, these three. And the first equation is the one that we're going to be working on trying to arrive at today, this idea of a permutation. So let's have a look at the question. And the question that I'm doing here says, in a class of 8 students, 5 are given an early mark to the canteen. In how many ways could students from this class line up at the canteen? So what matters here is the fact that in the end, the students line up at the canteen. If I just said 5 students are given an early mark, how many different ways could we pick those 5 students? That's actually not a permutation. That's a combination. And that's something that we actually teach after we do permutations. So the first one that we're going to do is a permutation where the reason why it's a permutation is order matters. If you're over at the canteen line and you're first in the line, you're a very, very happy camper. You're going to get to choose what you want. The food's going to be piping hot. If you're fifth in the line, you're like, oh, I hope those potato wedges don't sell out. It's not as good a place to be in the line. So where you are in the line is important. So if we have randomly got 5 people coming out of a class of 8 and then standing in a line at a canteen, can you predict how many different ways we possibly could do that? Like, let's just think in our heads. There's 8 kids, 5 different positions in the line, maybe 40, maybe more, maybe 200. Maybe there's a lot of ways that they could line up. But 200 seems excessive, right? You know, there's only 8 kids in the class. How many ways can they line up at the canteen? Seems a bit outrageous to say 200. Well, you might be shocked at just how many ways students can line up at the canteen. It's definitely not intuitive. So let's have a look and see how we would solve this. So what we would have to consider is how many different students could be first in the line. So there's 8 students in the class, so 5 of them are given an early mark. Any of the 8 in the class could have been the ones that were given the early mark. So there's actually a potential for any 8 students to be first in line. Then, of course, that leaves us with 7 students being second in line, 6 students being third in line, 5 students being fourth in line, and 4 students being fifth in line. And so the solution to how many possible ways that we could have this students line up at the canteen is 8 times 7 times 6 times 5 times 4. And what I want you to try and do is just recognize something here. What does this look like in terms of what we've just been talking about in the previous video? This looks like a factorial. So I could have actually expressed this as 8 factorial. But that would have caused a problem because then I would have had on the back here times 3 times 2 times 1. But I don't have times 3 times 2 times 1. So then you could ask yourself a question, well, how do we delete those? You know, in mathematics, if you are timesing something, how do you delete something that you're timesing? Well, you would divide it, right? So we could divide this by 3 times 2 times 1. But hang on a second. 3 times 2 times 1 is in the form that we've seen before as well. It's also a factorial. So this is 8 factorial over 3 factorial. And there's one more step that I'm going to get you to take, and that is there a way of expressing that 3 factorial where we could use that 8 that was on the top? How did we get from 8 to 3? We did that because there was 5 selections, right? There were 5 positions in the line. So I'm going to write 3 factorial as 8 minus 5 factorial. 8 factorial over 8 minus 5 factorial. So that was our 3 factorial. And if you look back at the equation that we have on our formula sheet, it is n factorial over n minus r factorial. So here, n factorial, 8 students that we are selecting from, 8 minus r, the number of selections that are made where order is important. This actually matches the equation that is given to us for a permutation. All right, we've held out long enough to see what the actual answer is. So we could plug this into our calculator just in this format, or we could just say 8 factorial divided by 3 factorial. So let's do that. 8 factorial divided by 3 factorial, and it equals what? 6,720 ways. Who would predict that from a class of 8 kids, if we just randomly pick 5 and line them up at the canteen, that there is 6,720 different ways that that could happen? It's almost impossible for humans to predict that the numbers are going to be that large. When you are required to do something in order, it is astronomically higher number of outcomes you can do it. You may have heard people talk about a deck of cards, that when you shuffle a deck of cards, you end up with a unique shuffle. People be like, no, someone else may have done this shuffle. No. 52 cards factorial. The number is so astronomically large that the chance of you shuffling just the way someone else has ever shuffled is almost non-existent. So you would just be the only person that's ever shuffled them into that way ever, as long as obviously they're randomized in terms of doing your shuffling. All right, so now my other point that I want to make here is actually the formula. So we spoke about this being on your formula sheet. It is there, and this n factorial over n minus r factorial is what we were using. But to the left of that, we can see that that's actually NPR, a permutation. A permutation of n, r selected from a group of n. So we have that on our calculator. Now I'm still using the old Casio FX82 AU Plus 2. Sounds like my first car, the old Nissan Pulsar. So on your calculator, you should make sure you can use that NPR option as well. So for me, I'm just 8 shift NPR, which is just behind my delete button, which is just completely rubbed off. Everything is rubbed off on my calculator. It's certainly not as old as me, but it is getting on. So R was how many selections we made? 5. So 8P5, and your calculator will give you that same answer, 6,720. So you don't have to go through this process. But I always say to students, go through this process enough times so that it is absolutely a concept that you understand why NPR is giving the values that it is, because the values that it gives are just completely unexpected. So at least make sure you've got the algebra or, the number theory down pat enough so that you are able to get it without just using the calculator and confirm that that number that you've got makes sense being that high. So yeah, maybe that's a question you could ask in class today, tomorrow, and just say, hey, if there were 8 of us and 5 went to the canteen, how many ways could we line up? 6,720 different ways.